Okay, so yesterday the application problems we did were pretty general. It was a flagpole. There was the one with the mirror, and you had to add the angle with the angle of elevation and the depression. You had to add those two, so they were pretty basic. We are now going to do some application with what Trig is used for. It's surveying and navigation, and so we need to learn some directions. So when we talk directions, it's the only time in Trig that we don't go to the x-axis, we go to the y-axis because we go with the north-south line. Okay, so this is the north-south line. In physics, you do a lot of drawing triangles based on the north-south line. So when I have this north-south line and this north-south line, I always put an arrow pointing north and an N to show everyone in the world it's a north-south line. And every single one of these lines are, guess what? What are they to each other? Not perpendicular. Parallel. Every single one of them are parallel. So if I connect them, I have alternate interior angles that are congruent. I have same side that are supplementary. So every single one of those rules that we've had before apply with parallel lines. Okay? So again, what makes it a north-south line is it has an arrow pointing north and an N. Without the N, it is not a north-south line, and you cannot make the assumption that they are all parallel. Am I clear on that?
Without that?
If you don't put the N there, it is not a north-south line, and I will not allow you to make assumptions that they're parallel, because that's what makes them parallel. Okay. So when we do this, we have to do at least the north-south line, but this all is here, which is the X and Y axis, yes? We have north, what's this one? North, east, bottom, south, and left, west. Okay, you need to know this because they will give you directions like south, 15 degrees west. South, 15 degrees west. So you always start on the origin, and south would be what? Down, and west would be left. And the 15 degrees, this is the only time it's different. The 15 degrees is with the north-south line. Because every other time I've said draw your triangle to what axis? The X. Okay, in navigation, it is not to the X, it is to the Y. So, north, 25 degrees east. So how would that be drawn? I start where? Origin and go? Nope. Nope. What's first? North. So I go up. Then I go 20 degrees left or right. Right. These are nowhere near what they should be. Does everyone understand how that works?
Do that again.
Okay, so north, 25 degrees east. So north, 25 degrees east.
Okay.
You always do your north-south first, and then your left-right. Got it? Mm-hmm. Okay. San Luis, California is 12 miles due north of Grover Beach. Okay? So, north-south line. Hopefully they look better than that. And it says San Luis is 12 miles due north of Grover Beach. So down here, is Grover Beach. San Luis is due north, so I stay right on my north-south line. Make sense? If Arroyo Grande is 4.6 miles due east of Grover Beach, so here's Grover Beach, due east would be what? Right.
What did you write next to the dot under the end?
What? San Luis, Grover Beach. Is it blurry?
No, I just can't read it. No, all of just.
Okay. So it says Arroyo Grande is 4.6 miles due east. So, well, if this is 12, we said this is 12 miles, right?
Mm-hmm.
It doesn't have to be exact, but 4.6 should not be as far as 12, right?
Right.
So 4.6. And this was Arroyo Grande. What is the bearing of San Luis from Arroyo Grande? So my bearing is my north 25 degrees east, south 25 degrees west. It's this direction. Now it says, I'm going to read it again. What is the bearing of San Luis from Arroyo Grande? So I'm going to make myself a north-south line at Arroyo Grande. And then I'm going to go to where? San Luis.
Oh, which one?
And I'm going to put an arrow this way so I remember that I'm going that direction. So where is my angle at? Is it inside the triangle or out of the triangle?
Inside.
Out. Because these angles are with the north-south line. And inside is not with the north-south line, is it? So I'm looking for this angle right here. The new one right here.
What do you mean?
I know, that's a shock. Okay, so, well, what does that little angle and the angle inside the triangle equal?
90.
90. They would be 90. That's a right angle, correct?
Yeah.
So if I find the inside, can't I subtract it from 90 to find the outside? Okay, so let's get our north, east, whatever. So we went from Arroyo Grande, we went up, so that's what? Is that north or south?
We set up.
I know, we went up, so is that north or south?
North.
North. Okay. And then did I go left or right?
Okay.
Left, so is that east or west?
West.
West. So now all I need to find is the angle that goes in there. So my theta and I'm going to call this alpha here, is going to be 90 minus alpha, right?
Mm-hmm.
Okay, so how am I going to find alpha? I'm going to find that angle right there. Hmm?
From the leg.
From the leg, so how am I going to find it? What have we been doing?
5%.
What?
How am I going to find alpha?
Oh. Tangent. 12 and...
Just tangent of?
Inverse to
Yeah.
Inverse tangent.
That's what I said.
So we're going to have 90 minus inverse tangent of 12 divided by 4.6. And we're going to put that in our calculator all at one time.
Why are we taking it at 90?
Because the inverse tangent of 12 divided by 4.6 is finding this inside angle, and we don't want the inside, we want the outside. And these two angles are complementary. Because this is a right triangle. We didn't put it there, we should have, huh? Because if it's not a right triangle, can we do this? Nope.
I put it there.
Good job. I did not. I failed.
Approximately 21.
I got,
21.
yep, approximately 21 degrees. I will always show you what I used to round. It's just something I do. Because if I round wrong, then I show somebody I did know what I was doing. Okay. So now a boat on a course of a bearing north 52 degrees 40 minutes east for a distance of 238 miles. Okay, so I'm going to read that again. This is exactly how I would do a problem when I'm doing it. I would read it, draw something, read it again. Probably going to get something. Okay, so it says a boat travels on a course of bearing north 52 degrees 42 minutes east. So I start with a
North line.
north-south line. Actually, probably don't want to start at the top of my problems. Probably want to start like in the middle or on the bottom. Because I'm going north, so I'm going what? Up? And you'll learn this just so you, if you're doing more. Okay, so I'm starting at this imaginary origin right here. And I'm going north and then east. So is that left or right?
Right.
Right. And it's 52. So that's over halfway. So this right here is 52 degrees 40 minutes. Can we do math with that? No, so we're going to have to change it, right? And then we go for 238 miles. How many miles north and how many miles east has the boat traveled? So I'm going to put another north-south line here because I've stopped. If I were going to change direction, it would be from that point, correct? So how many miles north and east? So what am I making?
Triangle.
A right triangle. Now, could I made it this direction too?
That's what I was.
If you want to make it that direction, is that okay?
Yep.
Yes. Okay, since these are parallel, I know that 52 degrees 40 minutes is also this angle here, because that would be alternate interior. So either one of those is fine to do. So we need to make this 52. I should have just put a theta here. And then we could have changed it. That would have been easier, right? 52 degrees, 40 minutes. How do I get from minutes to decimals? Divide by 60.
Mm-hmm.
So that, what is 2/3? Which is 52.66, right? And you should know some of those decimals. So this angle right here is 52.66. You guys want to use this top? And you don't have to transfer it. Or do you want to do bottom? Does it matter? You can use this 52.66, right? So it wanted to know how many miles north. So this is N. We're just going to call it N since there's already an N. And how many miles east? So how would we find our north? An angle. adjacent over hypotenuse. So what is that?
Cosine.
Cosine. So I have cosine of 52.66 equals north over 238. So my distance north would equal 238.
Cosine of 2.66.
Yep, cosine of 52.66. I get approximately 144 miles. Okay. So why don't you guys do east? And you guys don't have to retype that in. If you just hit second enter and change your cosine to sine.
Oh.
And on yours, Emma, you can just go up and hit enter.
Oh.
So I got approximately 189 miles.
Mm-hmm.
Okay, so the hardest part of these are going to be to draw the what?
Picture.
Picture. Okay, I'm going to show you the picture on the next one because it would have it in the book. And then we're going to draw that picture for ourselves. Okay? So here's the picture they have in the book.
Ooh.
And I'm going to read the statement. Says, figure 10 is a diagram that shows how Diane estimates the height of the flagpole. So the height of the flagpole. She can't measure the distance between herself and the flagpole directly because there is a fence in the way. Okay, that fence I could definitely put a tape measure under. They probably should have put a privacy fence. This picture bothers me every time. So she stands at point A, facing the pole, and finds the angle of elevation from point A to the top of the pole, so that's right here, to be 61.7 degrees. Then she turns 90 degrees and walks 25 feet to point B, where she measures the angle between her path and the line from point B to the base of the pole. So that'll be right here. I lost my place. Base of the pole. She finds the angle to be 54.5 degrees. Use the information to find the height of the pole. Now, I want you to look at the picture without the fence, without the sidewalk, without the grass. Is this a picture you have had already in your assignments? Yeah. So we're going to draw a basic picture here. Now, my pictures are usually more turned than theirs. Just because. I don't know why. They're not the prettiest, but they get the point across in my brain. So this is a right angle. This is a right angle. This is X. This is 25 feet. 54.5 degrees. And this angle here is 61.7 degrees. Well, they gave you a hint. You might need to find X, right? And the reason why you have to find X is what part of a triangle is in both triangles? Isn't that X? So, and in the triangle that's laying down on the ground, do you have two pieces? So if I have two pieces, can I find a third?
That's 61.7.
Yep. Okay, again, we have to start with the triangle on the ground because it's the only one we have two pieces of information on. We cannot do anything unless we have at least two. So, X is the part that of a triangle that is in both triangles, so it links it. So I'm going to use that. So once I have X, I can use tangent to find H. So how am I going to find X? I'm going to use tangent, right? So I'm going to have tangent of 54.5 degrees equals X over 25. So X is going to equal 25 tangent of 54.5 degrees. Do I care what X is? Do I actually need to know what X is? No. So guess what I'm not going to do? I'm not going to put it in my calculator. I don't need to know it. I'm not going to put it in my calculator. That is a value, yes. Okay, so when I put X into this new equation I make, I'm going to replace it with what? 25 tangent of 54.5. Okay, so now that I have a number for X, I have an angle, and I want the opposite, I'm going to use what again? Tangent. So I'm going to have tangent of 61.7 equals H over X. So multiply by X, right? So H equals X tangent of 61.7 degrees, but what is X? Yep, 25 tangent of 54.5 times, and then tangent of 61.7. Now I'm going to tell you in the book, if you look in it, look how they did it. They found X was 35.0487 feet. So then they had, you can't just round it to 35 feet, can you? Not if you're going to keep using it. So they have 35.0487 that they are carrying around in that other equation. Isn't it much easier to plug that one number in all at one time? Okay.
Bigger than that.
No, not X. If this is not X, this is the flagpole. If you plug in X, that's 35.
35 point.
Yeah, that's what I was saying. Okay, so now what is the approximate height of the flagpole then?
65.1.
65.1 feet. And we went to the 10th because everything they gave, like they gave me the angles and that was the 10th, right? Okay, here's another one. I'm going to show you the picture. It's the last example we're going to do. I'm showing you the picture because they would give you the picture. Okay, so we're going to read it. I'm going to read it to you. And then we're going to draw the picture, labeling it. Okay, so here's the picture. You see the helicopter? Okay. So it says, a helicopter is hovering over the desert when it develops mechanical problems and is forced to land. After landing, the pilot radios his position to a pair of radio stations located 25 miles apart along a straight road running north and south. So they put this at an angle. Could you put this at a straight up and down angle if you wanted?
Yeah.
Yeah. They just wrote it like this. Okay. If I were to draw this picture and they didn't give me the picture in the book, my line would be straight up and down and I'd have it over here. Okay. They just wrote it at an angle because you see how the north is still here? Okay. Now, here is the helicopter. This whole distance is 25. I would suggest you not draw your picture like exactly like this because I'm going to show you why in a second. Okay? We have a radio station at A and a radio station at B. The bearing of the helicopter from one station is north 13 degrees east. Is that A or B? North 13 degrees east. A. Because north, east is 13 degrees. And from the other is south 19 degrees east. So that would be this one. After doing a few trigonometric calculations, one of the stations instructs the pilot to walk due west for 3.5 miles. That would be this way. To reach the road. Is the information correct? Okay. So we need to put this picture on our paper.
Are we gonna put it up and down?
I am going to put it up and down. Does that make more sense in your guys' brain?
Yeah.
Okay. So the reason why I'm doing that is, do my pictures have to follow the same directions? Like, does it have to be exactly what's in the book? No, they do not. So, as long as your brain knows what's going on, do not take 6 years drawing a picture. Okay, so give yourself a north-south line. We're going to have station A and B, or it doesn't really matter what you name them. Okay, the picture in the book, put the pilot or the helicopter right here. What is wrong with putting it right there? What's it look like it is between these two stations? In the middle. Is it in the middle? No, because one was 13 and one was 19. So is that in the middle? No. Because if I put it in the middle, am I going to just try to divide 25 by 2 to get these two pieces? Yes. So put it, this is 13 and this is 19. So I bet it's closer over like here, correct? So it's north 13 degrees. I probably said that east. So that's, and oh, I put a dot and I didn't make it to the dot. So guess what I just do? Move the dot. So this is 13 degrees. And the other one is south. Oh, I did it wrong, but oh well. My brain was going backwards. Doesn't matter. Does that matter? No. And it one of the it doesn't tell me which station tells him, but one says to walk 3.5 miles due west. Well, due west would make it a what?
Right.
It would make it a right triangle. It'd be a straight line. Now, another one they like to do, guys, is the shortest distance. What is the shortest distance? Like from this point, what is the shortest distance to get to that road?
Straight line.
It would be that straight line, wouldn't it? It wouldn't be here,
Oh, the road.
or wouldn't be here, would it? If you need to write road over here, write road. Put what you need on there. But they won't say due west or whatever, but they'll say the shortest distance. And I have people give me this all the time. Are those...
That's silly.
These are not the shortest distance, are they?
Close. That's shortest.
Yeah. The shortest distance is going to be the height of the triangle, the altitude of the triangle. Now, may that be one of the legs? Yes. Okay, so the whole road is 25 feet. Miles. So we need to name one of them X and the other one 25 minus X. And we don't, which one do you want? You want the top one X, the bottom one 25 minus X, the bottom one, like
Top 125 minus.
this one up 25 minus X?
Yeah.
So that makes this what?
25.
X. Again, don't put your dot right in the middle because of the fact, unless it says directly between them, do not make your brain think it is, because that's what your brain is going to try to do. Make sense?
Mm-hmm.
So we are trying to figure out if this distance right here is D 3.5 miles. That's our question, right? I'm going to put a question mark. I probably should put a capital S or I. So how are we going to do that?
13 and 25 minus X.
Say that again.
13 and 25 minus X. Or 19.
We're going to have to make two triangles, aren't we? We're going to have to make an equation with this triangle, an equation with what?
That triangle.
That triangle. Because how many variables do I have? We have X and D, so we have 2, yes? So if I have 2 variables, I have to have how many equations?
2.
2. Okay, so what function, sine, cosine, or tangent am I going to use up here?
Tangent.
Tangent. So tangent of 19 equals D over 25 minus X. And then what about the bottom one?
Tangent of 13.
Tangent of 13 equals
X. No. D over X.
D over X. Now, I'm going to tell you right now, or what number do we want? Do we want D or X?
We want X.
We
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 want
want
D.
D.
we want D, so that means we need to get rid of X,
X.
correct? If X was easy to solve for, I would solve them both for X and put them equal to each other. Okay? Is X easy to solve for?
No.
Because it is grouped in that denominator with 25, isn't it? So what we're going to have to do is solve this one for X and then substitute that into
That one.
that one. And why would I solve this one? Because it's easier to do. So if I'm solving this for X, I would multiply by X, correct? And then what? What?
Divide by tangent.
And divide by tangent. So X equals D over tangent of 13. Now the book does it a different way. This is the way I think is the easiest way to do it. Okay. I know this is what X is. I don't want to put it in right at this point, right at this like second. Does that make sense? Because if it was multiplication, yeah, whatever. But it's division, and my brain just doesn't want to deal with that. So let's start solving this. So we can get this, let's get this out of the denominator. I don't want to put a fraction in the denominator, do you? Okay. So what do we do first?
Multiply it over.
Multiply it over. And these are the same steps we've had to do before, right? Multiply over and then distribute. So I get 25 tangent of 19 minus, well, should we probably throw in our x now? No, not yet.
I think we should.
I think we should too, because I think we should. Okay, so x is going to be d tangent of 13 times tangent of 19, so I could just put d tangent of 19 in the numerator, right? Equals d. Well, I've got a fraction and I don't want a fraction. So I've always said if you don't like fractions, you got to know how to get rid of them, correct? So what could I multiply every single term in this problem by to get rid of tangent 13 in the denominator? I'd multiply everything by what? Yeah, tangent of 13. And that's everything, correct? I'm basically getting common denominators. So it would be 25 tangent
for the end of first
of
period,
19
all 10th and 11th
times
graders
tangent of
to
13
report directly to the auditorium.
minus
Again, when the bell rings,
the tangent of
for the end
13s
first
are going to
period,
reduce out on the next one, right?
need all 10th and 11th graders
Because
to
when I distribute
report
this here, these are going to
the
reduce.
auditorium.
So then I have d tangent of 19, sorry, equals, and then d tangent of 13. So what am I solving for? D. So I need to do what?
Divide everything by tangent of 13.
Nope. I need to get d's all where?
Oh, I realize.
I need to add this. So I have 25 tangent of 19, tangent of 13 equals d tangent of 13 plus d tangent of 19. Now you're getting back into the same steps we've done over and over. Now I need to do what with the d?
Distribute
No,
or
factor.
opposite.
So d tangent of 13 plus tangent of 19. And then I have to divide by this. So d equals 25 tangent of 19, tangent of 13, divided by tangent of 13 plus tangent of 19. When you put this in your calculator, you have to put parentheses around the numerator and the denominator, or you will not get the correct answer.
Parentheses or brackets?
It doesn't matter. I put brackets personally, but parentheses are fine. And you should get approximately 3.5 miles. So was he right? Yes, but make sure you can get that in your calculator.